All right, folks, welcome back. We're going to talk about square foot, square meter estimating. We're going to teach you how to go through this because it's such a quick and easy method to get an initial estimate for a project. Again, my name's Tom Glardner, and you're welcome to get a hold of me anytime you need. Here's my contact information. But if you remember, square foot, square meter estimating method is I've got a facility that I'm going to be building, and what I need to do is I need to just come up with the square footage of that facility, whatever the measurements are, and then I'm going to be able to generate a price. It doesn't matter what's going on inside the facility. I'm just going to generate a price based upon the size of it. So we're going to talk through how you do this, explain when it's appropriate, explain what the process is to do it. And I want you also to make sure that you carry away with you the risks. This estimate is useful for the initial planning of a project. And so that's why we're teaching it to you. But we also have to realize there's a risk with it. And how do you communicate those risks? How do you make sure that those risks stay with that figure so that people don't run off and try to do more with it than it should be? So we're going to talk about the square foot estimating method, when it's appropriate and when it's not, and when we'll talk about an example. And the reason I got this little symbol over here is sometimes people call this the straw man estimate, which is a term for something that you use until you replace it later on. So according to the UFC and according to the American Society of Testing Materials, which is an international or national standard, the square foot, square meter estimating method is used when you've got to develop a project that's developed enough to be able to measure the space. Generally, you've got very little project definition, less than 5%. I told you before you need to have 4 things. You need to know the type of facility, you need to know how big the facility is, location of the facility, and the date of construction. And if you know that, you can come up with an estimate. It's useful for long-range planning, but it's going to be very inaccurate. So you got to be very cautious about using this and what the numbers are going to be used for. So when do you do it? When you got to put numbers into print. Never, ever put WAGs into print. Danger, danger, Will Robinson. Don't put WAGs into print. They will run away with you, and you will not be able to control it thereafter. If you're still able to adjust the cost, in other words, you're pre-programming. You haven't made any commitments to the higher headquarters that this is what the number is going to be. So you're just using a number just to kind of get things going. All right, that's fine. And if the numbers are wrong, and they're going to be, they're not going to be accurate, can we do anything about it? As long as you're able to do something about it, then all right, you can use the square foot, square meter estimating method. You don't do one for 1391. So the emphasis here, if you're dealing with the DD Form 1391 or if you're dealing with our automated systems, don't put a square foot, square meter estimate into those. Those numbers will run away and you'll lose control of them. Don't use them on projects requiring a certified estimate. Don't use them for data calls this year. And just because you don't have enough time doesn't mean this is the method to use. It's going to be, you're putting a lie on paper. You have to accept that if you use one of these things. So the process for all estimating, you come back to our 400 course, you're going to see this same process over and over and over again. If I've got to come up with an estimate, where do I get my numbers from? Where have we ever done something like this before so that we can use those numbers and then apply to this situation? So that's identify some sort of historical data. It's always best if it's normalized. Your experience is not normalized. My experience is not normalized. It's usually you've gone through some sort of statistical analysis of your data and came up with a good average cost for various different types of things. Then you're going to adjust it for the situation. Commonly, we adjust it for the location and the size and the date of construction. We'll talk about how to do that. But there's other types of adjustments that are out there. And then you apply some markups that are unique to working in the DoD. Hey, we've got cybersecurity issues we got to deal with, so we're going to throw a markup on there for that. Or we got anti-terrorism issues that we might have to throw some markups on there. So we'll address these markups later, but these are the 3 steps. Get the historical data, get an unadjusted price, adjust it, and then mark it up. Now, there's 2 methods that we want to talk about in this course. It's essentially the same square foot, square meter estimating method, but people tend to think of that repair as something unique, something just, it's not like building a new building. We're going to just do a repair of the building. So I'm going to talk you through how you come up with a repair. But I'm going to start off by teaching you how to do new construction. And the main reason I'm doing that is because repair requires you to know what the construction cost is. So we've got to know how to do this first. By the way, we're going to kick a term around called guidance unit costs. That's called the GUC or GUC. Guidance unit cost just means the square foot square meter price. It's just a fancy DOD term for the same thing. So we're in new construction, and to do this, I want to run through a scenario. We're going to follow through this scenario, and we're going to all go down the road together. We're at McConnell Air Force Base. By the way, McConnell Air Force Base, this is all made up. I just made this stuff up myself. We're at McConnell Air Force Base, and we need a flight line vehicle maintenance facility. We've got a new KC-46 facility requirements document that's coming in. It's draft form, and we're going to we need a new facility in October 2025. The date of construction is going to be in fiscal year 2025, but we got to figure that when we contract this thing, as it goes on through construction, midpoint of construction is probably going to be around October 2025. We'll see how that's important later on. So we've got a new Air Force Form 332 that's been submitted by the logistics group, and we need to do an initial planning cost for this facility. And per the Air Force Design Guide, we've gone through the calculations. You don't have to do that for this course. This is something programmers need to be able to do. But they've gone through the calculations, and they said, you know what? We need a 19,150 square foot facility. Otherwise, convert that thing to meters. It's 1779 square meters. So this is the entry point. We know the type of facility, right? So it's going to be a vehicle maintenance facility. We know the size of the facility. We know the date of the construction, and we know the location of the construction, right? We know those four things. We can do a square foot, square meter estimate. So is it appropriate at this time? Well, we're putting numbers into print. We got an Air Force Form 332. We got to process that and put it into the programs. It's in advance of building the project package. We know that we haven't got any more details than what we've got right now. And we presume that we're still able to adjust those costs. We're not dealing with the DD Form 1391. We still have to get the money to run the siding and the charrettes and all that other kind of stuff. And if it's wrong, we're prepared to, and we make sure that everybody else is prepared to adjust the costs. So we're going to say, for this example, yes, it's appropriate. So what we do is we go into UFC 3-70101, and this is the most current one as of the filming of this project, but you can imagine it's no different. If this thing gets replaced in the summer of 2020, well, then you've just got more updated data, but it's the same process. Okay, so for the purpose of this course, we're going to use the one that's February 2020. This is also true for the homework. I've got it posted on the site. The 2020 version is posted there. So we're going to go down through the first table, Table 2. We go down through Table 2, and we're looking for vehicle maintenance. So we come down here. Oh, there's maintenance shops down here. So we're going to go down through maintenance shops, and we find out the first one is vehicle maintenance facilities. And we got to ask ourselves, are we dealing with a large one, or are we dealing with a small one? And it defines that for us. Greater than 21,000 square feet, less than 21,000 square feet. If you remember, we're at 19,000 something square feet. Looks like we're down here in the small facility, right? So the next thing we look at is the reference size and the actual cost this is cost per square meter, and then the next thing is the reference size and cost per square foot. And those are the figures that we need to pull out of this thing. The other thing I want to bring to your attention, you don't have to be a statistics person. This course does not require you to be a statistics person, so don't worry about it. I'm not going to ask you questions on a quiz about it, but look over here. I've got a 39% standard deviation. That means one standard deviation of variance, which includes 64% of normal variance, okay? 64% of your normal variance of projects is going to fall within 39%. That's way outside that 25%, folks, right? And then you take it 2 or 3 standard deviations, dare I say 6 sigma, if you're familiar with that term, and you're way out there. So just realize that this data is telling, what this is telling me is that this is not very accurate data. So I want to emphasize that mainly because that whole plus 50 minus 30, that's not something I'm making up, folks. The data itself, where we got these costs from, is telling us right away it's not very good data. So it's got to be used strictly for planning purposes. We need to communicate the levels of accuracy along with this. So we're going to capture those costs. Here I just replaced it here. We got a small facility. There's the cost per square foot, and there's cost per square meter, and the cost per square foot, and the accuracies are all over there. So we're going to use the cost per square foot in this exercise. Now we got to hold on to that reference size and just kind of put it in your pocket. We're going to come back to it. I'm going to explain why, but we're just going to hold on to that reference size. We need to remember that this cost data is based upon a vehicle facility of that size, 8,000 square feet. Now, what's included in this data? You got to know that stuff because you got to know what kind of markups and adjustments you may need to make. This data already includes anti-terrorism per the UFC. It says that. So that means I don't have to do any anti-terrorism stuff to this facility. It does include contractor overhead profit, so I don't have to put any overhead profit in this. That's good news. It does not include supporting facility costs. We'll talk about that in another lesson, although I'll give you a quick method to come up with supporting facility costs. It does not include supervision, inspection, and overhead, and that is our cost of managing this project. Doesn't include design, contingency, or user equipment. So we need to think about whether or not we need to add those in our examples. And per the business rules, we've got to add cybersecurity. That's another thing we need to throw in there. So these are things we need to consider adding to the project. These you don't need to add to the project. So you need to read the UFC if you're actually going to use this and make sure you know what's included in the cost. Now there's another table in there. Let me caution you about this other table. You're going to look at table 2 and say, well, there's some costs in there. And then you're going to look at table 3 and go, wow, that's detail. And here you go, replacement costs right here in this column right here. Hey, Tom, why can't I use this table to come up with the replacement costs? I mean, there's the cost right there. And the answer is because it says don't use this table for construction projects. Don't use this table for projects. This table is for the real property folks to generate something they call the plant replacement value. And that's just some sort of real estate, real property evaluation of what the investment the DoD has in its infrastructure. And it's useful for that purpose. But if you were to compare, if you were able to find on the previous table a cost for a facility and then compare it to the cost for a facility in here, you're going to find out that these costs are something like 20% or 30% or even 40% below the previous table's costs. They're wrong. These are low because they don't include everything in that facility. They just include what they call capitalized costs, the things that are recoverable costs in a facility. So the key thing to remember is never use the dreaded evil table 3. It's not for estimating purposes. It's not for what we do, and it says so right up there. Just so hopefully everybody's on board with this. Stay away from the evil table 3. So now we know we have a 19,150 square foot facility. We know the cost per square foot. Multiply those two together, we come up with a $7,296,000 project. It's just that easy. This is our unadjusted cost. So we're at the end of step 1. We've got the unadjusted cost based upon the cost per square foot and the size of the facility. So let's go to step 2. We're going to start doing our adjustment. Now, we've got to adjust this thing based upon a number of different situations. One of those is the size. Our facility is supposed to be 8,000 square feet. That's what the cost data says we base the size on. But our facility is 19,150 square feet. We're building a lot larger than what the data is based upon. If we're building larger, if you build bigger, do you think that your cost per item, cost per square foot, is going to go up or down? Think about that. Think about economies of scale. Think about the fact that your contractor has to mobilize for a lot of work or a little bit of work. Think about the fact that they're going to be transporting stuff out and on trucks, and they might have to transport out 5 pallet loads of brick, or they're going to bring out 2 pallet loads of brick. I mean, it's the same cost of transport either way. What if we were able to get a lot of bulk rates and bulk pricing and things like that? So the larger you build, you get more economy. So we've got to figure that out somehow. Well, the way we do this is first, we have to develop a size ratio. And the size ratio is the size you want to build, the to build, divided by your reference. And if you need to write that in the column over here, make sure you emphasize to build divided by your reference, because the most common mistake folks make is they flip those. So always to build divided by the reference. Everybody cool with that? And if we did that in here, we're going to come up with a size ratio of 2.3938. Now that means we're building over twice the size of our reference facility. We expect the number to go up quite a bit, or go down quite a bit. And what we see in the real world is a ratio of pricing. Basically, it says if the larger you build from the 1-to-1 ratio, so this is a size ratio, 1-to-1, the larger we build, the lower the price will get. It's not a straight line lower, but it's lower. And the smaller we build, the larger the price will go. So it's going to go up. It's kind of an inverse ratio. So what we're going to do is we're going to go into UFC 3-730-01, and you will find, this is a different UFC, by the way. I've got this one posted to your website as well, so you can get both UFCs. You're going to get this table 1. It's on like the second or third page. You're going to leaf down, find table 1. And what they have is the size ratios in one column and the adjustment factors in the other column. So we got this 2.3938. We're going to go in here and look for the 2.3938 as our size ratios, and it's going to tell us what the size adjustment factors are. I've blown it up so that you can see it bigger. Okay, everybody cool with that? Instead of trying to figure out what this thing, trying to squint at the screen, I've got it bigger. So what we have here is it's in between these two figures, between 2.35 and 2.40. And if you come back to the 400 course, I'm going to make you interpolate things, because you're always interpolating in cost data. You're always trying to figure out where in between the cost will be. So we take you through the goat rope of interpolation. In this case, interpolating it would be 0.9311. So it's in between these two guys, and it's really close to this one right here, because obviously 2.3938 is real close to 2.4. So that's what the number would be if you interpolated. In this course, you're just going to choose the closest. Whew. All right, so no interpolation required for you folks. We're just going to use 2.4. So the number we're going to use for this example is 0.9310. So it's obviously closest to this one. You're going to use 0.9310. That's your size adjustment. So that should, by the way, make sense. I'm building over twice the size. My price should go down. Not a lot, but it's going to go down some. Now the question is, we're going to build at Wichita, Kansas. Is Wichita, Kansas more or less expensive than the national average? So we're going to go out there and start evaluating that. Now the UFC provides us some adjustments. We're going to see those adjustments. But those adjustments do include the labor and material and equipment availability at your location. I often get the area cost factors don't consider the fact that we're in a location where the labor is just not available. But, yeah, they do. Yeah, that's what it's all about. That's why we have it. It doesn't consider the fact that we've got some unusual situations here with the tornadoes in Kansas, or the hurricanes in Florida, or the snow in Thule, Greenland, or whatever it might be. Yeah, they do. They're based upon real costs, by the way, from your area for the last 3 years. So those UFC costs are representative of your area costs. And they do consider availability, the productivity, the fact that you don't have skilled labor, or the fact that you may have to have different types of means and methods. All of that is considered in the pricing of an area cost factor. The key thing that you probably frustrates people the most is that it's a moving average. It depends upon the national average for DOD. So your prices may not actually go down. They may actually go up in your area over a year, and your area cost factor might go down, because as a national average across DOD, you're no longer where you were before. So those averages change from year to year. So we're going to go into the UFC 3-701. That's the one where we found our pricing data, table 2. we're going to go to table 4-1 in that UFC, and we're going to pull up the area cost factors. Now, when you're going into this table, it is a lengthy table. It goes on for page after page. It's a spreadsheet, actually. And it's got a lot of data in there. If you start searching for McConnell, you're going to find McConnell Street on Arnold Air Force Base. You're going to find McConnell Avenue in Montgomery, Alabama. You're going to find all kinds of McConnells all over the place before you finally find the one that you want. So I'm going to tell you the trick to navigating this table. The trick is find the zip code. Typically, in almost every case I've ever seen, the zip code always brings you to the base, and everything that has the same zip code tends to have the same area cost factors. So we're going to use the zip code 67221 is the zip code for McConnell. I used to live there. And you go right down through the table, you come up with Wichita, Kansas, and we find the area cost factor is 1.0. Now let me warn you something about this. You'll also see a sustainment area cost factor. That sustainment area cost factor is for the evil dreaded table 3. It is for those plant replacement values. Normally it's smaller than the area cost factor. In this case, it just happens to be one larger. But never, ever, ever, and I mean ever, folks, use the sustainment area cost factor. It will lead you astray. Always use the area cost factor column, the first column that you have there. In our case, it just happens to be, on this particular iteration this year, McConnell Air Force Base represents the national average. So if you want to know what is the national average at this point in time, McConnell Air Force represents that. Now, it may not be next year, it may not be the year before, but just this year it happens to be. Again, never use that evil column. All right, so we've got our sizing factor. We've got our location factor. Now we've got to escalate our costs. That means we've got to bring them up to 2025. Now there is a table 4-2 that will do that for us, but I'm going to warn you, there are a couple other tables you're going to say, well, there's some escalation tables. Can't I use those? 4-3, 4-4? No. Those are for the evil dreaded table 3. Stay away from those tables. Those are for those plant replacement values. Stay with the 4-2. Now it looks like this. In fact, this is the table. But what you're going to find is there's a lot of historical data over here. And if you come back to the 400 course, I teach you how to use some of that historical data. But because this UFC has already baselined itself with the year of the data, and in that case, the year of the data is October 2019. So it's based on the October 2019. The the escalation factor that you need to have is essentially the midpoint of construction. And you pull that escalation factor right off the table there. You don't have to do any fancy math. You don't have to do any ratios. Again, come back to the 400 course if you want to learn how to do those things. We teach you that. But for our purposes, we're just using this table to modify this cost data. I just need that factor right there. And make sure you're pulling it off of this side, not this side. We're looking for midpoint of construction, not the fiscal year that it's occurring in. So we have a size factor, we have the location factor, and we've got the escalation factor. We are ready to start adjusting, folks, but that's not all you can have. We've got some other adjustments you can grab out there. If you're dealing with the dormitory, you can do some adjustments based upon the number of airmen that you might have in that dormitory. You just go to UFC 3-730-01, go to table 2, and it's going to walk you through that. There's 2 UFCs I keep switching between, by the way, folks. Remember this. 70101 is the one that's got all the cost data. 73001 is the process. It shows you some of the tables, but it's primarily the process of how you do this. You can go to table 3 if you've got housing, so you can talk about the price per unit. Table 4 says we've got a technologically advanced facility. I want you to imagine a facility like medical facilities where the technology is advancing so rapidly that we expect it to change throughout design and construction. But what we've scoped today is not going to be the same as what we're scoping tomorrow. We got to be prepared for that scope to change. And we actually have a table 4 that actually picks out what facilities we're able to apply this to. So if it's a research, development, test, evaluation facility, like your labs, if you're some base with labs like Arnold and Eglin and Wright-Patterson and Hanscom. Those folks with labs can add a 10% adjustment factor for the fact that the project's going to change throughout the process. Medical facilities, as I mentioned before, medical facilities, the technology changes every 3 years. So if you're not, within a 3-year window, you're going to have to redesign this facility. You get a 5% adjustment factor for that. And the rest of these, all the rest of these are all utility plants. And the idea here is that utility plants, because of efficiencies and economies and control systems, they are going to change every couple of years as well. So you've got some adjustment factors there. Those are the only facilities you can apply this adjustment factor to. That's all. If you're using it, make sure you explain it. And because we're dealing with a vehicle maintenance shop, it's not really appropriate to our particular project, but nonetheless, this is available to you out there if you want to use it, if it's appropriate to your project. So we've already looked at technology adjustment factor. There's another thing out there called design contingency. Now, this is not construction contingency. Construction contingency, which we'll talk about in a couple more slides, is contingency you throw in your project for unknowns, things that you're digging into the project, you're actually executing the project, and all of a sudden, oh, there's asbestos, or oh, there's a buried foundation, or something like that. Those are the things you have construction contingency for. Design contingency is to cover the fact that we haven't even started designing this thing. We're at less than 5%. So we're going to have some contingency in there that says, as we're designing this thing, things are going to change, and we're going to have to adjust to make the design work. So given the fact that we're pre-designed, we've got to have some contingency to cover the design period. And there's another table out there. Now you have to assess, are we in a facility that's highly complex? We already saw what those facilities are. Or are we in something that's routine or somewhere in between? And you'll have to assess that yourself. Then you ask yourself, are we in the early stages, or are we at least at a conceptual stage? So you can assess whether we're going to be pulling off something that's at the 5%, which is what we're discussing for this methodology, or are we at the conceptual stage? So for our facility, it's a vehicle maintenance facility. We're going to call that routine because we build these things all the time, all across DoD. And we're well early in the stage of the process. So we're going to call this thing a 5% design contingency. Here's the foot stomp, folks. You can't use this in programming. We're using this in a planning estimate. It's for square foot, square meter estimating. It's perfectly appropriate to do it there. But do not use this for DD Form 1391s. It's not appropriate to parametric estimates because you've already considered and done their charrettes and came up with their concepts, and you're able to quantify the scope of the project. So this is not appropriate for that. On the other hand, it is perfectly appropriate for square foot, square meter estimates for planning purposes. So we're going to throw a design contingency of 5% on this project. So now we know our adjustments. We've got our initial price, $7,296,150, and we're going to now throw in a size adjustment, 9.931, a location adjustment of 1.0, an escalation factor of 1.1262, and a design contingency. Multiply all those guys across, and by the way, remember, these things all multiply. Almost every one of your adjustments and markups multiply. And we come up with a new price of $8,032,454. Now that's your adjustment. That's your step 2. Now we go into the markups, and you have to go into, all right, you have to ask yourself, what program are we in? Because different programs will use different markups. In the military construction program, which at $8 million, we're in the military construction program, right? In the military construction program, we have to have a cybersecurity facility adjustment. And the programming policies out there have a whole bunch of discussion of what cybersecurity adjustments are appropriate. Essentially, we're going to use for this course 2.5%. But it could be higher or lower depending upon the type of facility and size of facility. We already know, if you remember, we know anti-terrorism is included in the cost data. We don't have to adjust for that. We knew the contractors over in profit is included in the cost data. We don't have to adjust for that. We do need to throw contingency on there because contingency is appropriate in the MILCON program. We use 5% for that. And we use supervision, inspection, overhead. Again, that's our That's our cost to manage the project. We're going to have to hire the Corps of Engineers and Naval Facilities Command. We're going to have to pay them a fee. And inside the continental United States, that tends to be 5.7%. So we're going to use 1.057. And that gives me a total price of 8 million times 1.025, that's cybersecurity, times 1.05 for contingency, times 1.057 for SIOH. Gives me a $9,137,689 project. Now, this is the important thing to remember, folks. This is primary facility only. What do I mean by that? We're going to have a class on supporting facilities, okay? So if you've already had the lesson on supporting facilities, you kind of get this. But we're just talking about the building for the vehicle maintenance facility. We haven't talked about the drives, the utilities, and the comm infrastructure, and all that other kind of stuff that has to be site developed so that you have this vehicle maintenance facility. So we need to think about those supporting facilities. Supporting facilities, again, site-specific requirements. So they're typically outside the 5-foot line of the facility. They can include things like demolition of old facilities, utility runs, pavements, comm support, environmental remediation, a lot of different things. Again, I'm going to talk about this in a supporting facilities lesson. And it varies widely depending upon the site, depending upon the base. It can be between as low as 5 or less %, all the way up to 50%. Although it tends to be less than 25%. So if you have more than 25% on a project, expect higher headquarters to ask you questions about it. But that doesn't mean it's wrong. It just means that they're going to ask questions. You need to justify that. Now, because it varies so widely, it really lends itself, and we'll talk about this in the supporting facilities lesson, to an analysis. You've got to get in there and actually pick out what your supporting facilities are. But for the purpose of the square foot, square meter estimating lesson, in our methods, would it be valuable to know what the average would be? We've got cost data that runs back 20 years. We know, based upon projects that extend across a long time period, we know that we've got a lot of different facilities built of a particular kind, and we can then look at what the average cost is for each of these facilities. See, for example, 21 different projects over a 10-year time period in this particular sample of child development centers. That's what a CDC is. If I look at those child development centers over that 21 different projects, I find, well, there's one that's 5.26%, but then there's one 52.38% supporting facilities. But overall, I can say here's what the average is. So let's see what you can do with that average. What it's going to do to help you. For a quick estimate, for something you can do immediately without having to shred or anything like that, what can we come up with? Well, first you have to come up with the primary facility cost. Did it, right? We've got that number. That's that $9 million figure. Then we got to find out what the percentage of average supporting facilities costs are. And I have prepared for you, at no extra cost, okay, a document that actually covers all that. I basically went into historical cost data, pulled those things up, and generated a list of supporting facility percentages. Those things are available, and you can click on that link in your homework, and it'll come up. And it's organized the same way that that table 2 is organized for your cost data. So if you've got a vehicle maintenance facility large, and you got a vehicle maintenance facility small, you've got a vehicle maintenance facility small in this data that you can go to. Then what we have to do is we can't just multiply those two together. It doesn't work. It doesn't work that way. What you have to do is you have to come up with the primary facility percentage. So you take 100% minus the supporting facility percentage, and it gives you the primary facility percentage. So whatever that percentage is, take 100 from that, or 100 minus that, and it'll give you the primary facility percentage. Now you can come up with the total cost by dividing primary facility by the primary facility percentage. So this is the steps to doing this. Let's show you how it's done. So we've got our primary facility. As I said, check, got that. Now we're going to go into this document and find out what the percentage of supporting facilities are for vehicle maintenance facilities. So we go in there, and it looks a little bit like this. This is 2 pages of it, but we got all these different facilities we found in that table 2 before. And we come over here, and we find, oh, here's our small vehicle maintenance facility. We find out that the price is $12.46. That's the average price for a average percentage of supporting facilities for a small vehicle maintenance facility. So 12.46. That means we take 100% minus 12.46, and our primary facility percentage is 87.54. All right, so 12.46 is percentage of supporting facilities. Our primary facilities is 100% minus that. Now we can come up with the total cost. The total cost is that primary facility cost, $9.137 million, divided by that 0.8754 that we figured out before, and it comes up with a price of $10,438,302.22. Now here's the problem. If I write down $10,438,302.22, people are going to think, well, that's the number. That's the exact, I mean, if he's down to the penny, he's got the number there, right, folks? It looks really smart. But the problem is we know it's really off. We know that the standard deviation is really off. We know that this methodology has some inherent inaccuracies with it. So you have a responsibility to communicate the risk. Now, how you communicate that, I'll leave that up to you because your boss is going to respond to different things different ways. Do you say it's $10 million plus or minus $5 million? Or maybe that'll work. Or you say $10 million plus or minus 50%. Or I've actually taken these two figures and figured out what the range is. 30% less than that, it's going to be 7.3. In other words, this times 0.7 gives me 7.3. Or 50% greater, 150% of this number is 15.7. I mean, that's how I might communicate this. But either way, you've got to communicate that risk. That tells your boss that this number's not right. It could fall in this range at this time, but we still have to do a whole lot of homework to actually nail down that price. The risk is that it goes up, ends up on the DD form 1391. You're going to get some sort of supplemental MILCON funds, and then you're in the cost overruns, and your boss is now answering to Mr. Carell at SAF IEE, what went wrong. And because it's years later, nobody realizes that this was something somebody did on the back of an envelope on a Friday afternoon. Or maybe they don't want to admit that. So we've talked really quickly through the square foot, square meter estimating method. We talked about it and when it's appropriate and when you should use it. And then we also walked through the process. Your homework, you'll get a chance to walk through the process again. Now, there's also risks with that, and that's the other foot stomp I want to make sure is that you should be preparing your leadership for the risks as you're communicating the costs. They're useful to a point, but they have risks associated with them, so you need to make sure that you're communicating that risk. So let's take a break, stretch, go to the restroom, get yourself a couple of drinks, and then we're going to come back and we're going to jump into the square foot, square meter estimating method part 2, and we'll focus on the repair portion of that.